right, so let's continue on with the inverse. Okay, finding the inverse. So, just like yesterday, the process begins exactly the same way. It doesn't matter what type of function we are dealing with, the process is exactly the same. We want to start by switching our x and our y. So we're going to rewrite this equation as x equals 4 to the y. We've got to get y by itself. Here's what's different, is the process of getting y by itself. Okay, do y'all remember solving exponential equations like this? When the variable was in the exponent, our only choice was to write this in logarithmic form. Okay, so it's log. The base was the same for the base of the logarithm. So the base of the exponential was 4, so the base of the log is 4. And then the other two parts of the equation just switch places. So the 4 was with the y. Now the y needs to go on the other side of the equal sign. And that's it. Okay, we've got the inverse. We've got y by itself. The inverse of this function of f is log base 4 of x. Okay, let's look at g of x is equal to e to the x. Rewrite it as x equals e to the y. We need to put it in logarithmic form. That's the only way to get the y out of the exponent. Now, this is the one that we didn't spend a lot of time talking about, but I mentioned it a couple of times. When the base is e, it's not the log, it's the ln. Okay, that is also a logarithm. It's called the natural logarithm. We don't write a base because the base is always e. Okay, the ln does not have a base. It's always e. So g inverse of x is equal to the natural log of x. Okay, that is also a button on your calculator. It's right below the log button. Okay, let's look. I'm sorry? I mean, that's all you can do with it. Okay, let's look at two of them that start with logarithms. Okay, they start with logarithms, and we're going to find their inverses. So we begin by switching x and y. X is equal to log base 5 of y. The y is inside of the log. We write it in exponential form. Remember the swoop? We start with the base. We go around our equal sign. So it's 5 to the x is equal to y. And that's it. Oops, it's not f, it's h. H inverse of x is equal to 5 to the x. Okay? Logarithms and exponentials are inverses of one another. Okay, so similarly, example D here, k of x is equal to the natural log of 3x. Switch x and y, so x is equal to the natural log of 3y. Okay, the base of the natural log is always e, so that's e to the x equals 3y. We got to get y by itself, so we divide both sides by 3. So k inverse of x is equal to e to the x over 3. Okay, so pretty simple. It's just converting. It's going back to converting between logarithmic form and exponential form. Okay, let's look at example 4. We're not going to look at part A. That's why I have that big X through it. But we are going to look at part B. Sometimes I would not be surprised if they ask you to determine an inverse that only has some random points, okay? It doesn't have a function rule. It doesn't have an equation. So we can't go through the process that we've just been doing. But they just give us a set of points and say either graph the inverse or ask you about a specific point. So go back to the very beginning of when we were talking about inverses. What did I say? X and y switch places. So what we're going to do with these points is we're going to take them one at a time and we're just going to switch x and y. So let's start number 5. If on the original function we have the point -5, -3, then for the inverse, those just switch places. We're going to have the point -3, -5. Okay, we're going to have the point -3, -5 instead of the point -5, -3. Okay, the next one, -2, -1, the x's and y's switch places. So we're going to have the point -1, -2. I'll explain why I have that line through the middle here in a second. Okay, so we've done that one, we've done that one. -4, 0 will be the point 0, -4 on the inverse. I don't think that I can write the points small enough, so that's why I'm not labeling them, I'm just graphing them. Okay, -3, +1 will be +1, -3. -1, +2 will be +2, -1. 0, 4 will be 4, 0. 2, 3 will be 3, 2. And 1, 5 will be 5, 1. Okay, now remember yesterday when we were finding, I showed you this on the quadratic functions. Okay, I graphed the quadratic and then I graphed the square root function, and then I also graphed that line y equals x, and I told you to turn your head and see the mirror image. The same thing applies right here. That's this line right here through the middle is y equals x. So if you're looking at your paper, turn your head, or turn your paper, actually, that would be the easier thing to do. Turn your paper so that that line is straight up and down, and you should see that if I take these points and flip them over that line, they're going to end up where we plotted those points. So these red points are the points of g inverse of x, because they told us that the original was g of x. So those red points there are the points that are on the inverse function. Okay? All right. So let's go back to looking at some graphs really quickly. Okay, we talked about this at the very beginning yesterday. The question is, which of the graphs below show functions that have an inverse that is a function? Okay, so we are looking at the original function right here for graph number 1. Will its inverse be a function? What are we looking for? What are we looking for? Anybody remember? Okay, the vertical line test determines whether or not this is a function. Okay, so let's talk about that. Is f of x a function? Does it pass the vertical line test? Yes, it does. Okay, we take a vertical line right here and we pass it along our graph. We are only touching it at one point at all times. Okay, so f of x is a function. The question is the inverse a function? Is the inverse a function? So what did we say? Let's go back. Let's flip over our paper and look at, whoops, one too many. What were we talking about here? Okay, here this one was a function and its inverse was a function. We called it 1-to-1. What made it that way? What was the difference between this one? What was the difference between g of x in this example and f of x? There's only one y for every x, and there's only one x for every y. Okay, there's only one x for every y. Here, there were multiple x values for every y value. So that's why this inverse was not a function. This inverse is. So let's go back to our graph for a second that we're looking at. Is there only one x value for every y value? Is there only one x value for every y value? Yeah. Okay, there is. Let's compare it to graph 2 to maybe help you see it a little bit better. Okay. How about this one? If I'm looking at, let's just look at y equals 0.5. That happens here, and here, and here, and here. It happens 4 different times just in what we can see right here. So this inverse, the inverse of sine of x, is not a function because every y does not have just a single x. This y right here, just this one, I could have picked a different one. I could have picked 0. It has 1, 2, 3 x values just that I can see here in this window that it's graphed. Okay, but graph 1, if I pick y equals 1, that only happens one time. If I pick y equals 0, that only happens one time. If I pick y equals -2, that only happens one time. So graph number 1, its inverse is a function. Okay, f inverse is a function. Graph number 2, g inverse of x is not a function. Okay, g inverse of x is not a function. Turns out, I don't think we talked about this yesterday, but we can use the horizontal line test to determine if its inverse is going to be a function. Okay, you take a horizontal line, and if it touches your graph in only one place at a time, then your inverse is going to be a function. So graph 1 is good, okay? But graph 2, we take a horizontal line. See how many times we're hitting the graph? Just about anywhere we move it, we're hitting it multiple times. So graph 2 fails the horizontal line test. So the inverse is not a function. Okay? I'm going to put that in parentheses here. Horizontal line test. Okay, last thing that I want to talk about real quick here is a multiple choice strategy. Okay, a multiple choice strategy for doing this, because what if you get to the final exam or you get to the test in the next couple of days and I ask you to find the inverse function and you just completely forget how to switch x and y and solve for y. Well, this will work on any of these inverse problems, okay? Here's what we're going to do. We're going to pick a number for x. 5 is usually a pretty good choice, okay? You don't want to pick something like 1 or -1 or even 2 or -2. A lot of times, sometimes those can have exceptions to them. So 5 is usually a pretty good choice. We're going to plug that into the function that they give us. Okay, we're going to plug it into the function that they give us and find out what the answer is. We're going to take that answer and we're going to plug it into all the inverse options and see which one gives us back out 5. Because remember, a function and its inverse switch x and y. Okay, so let's look at an example. Okay, now you're not actually going to have to do a 5th root one. Okay, but this was just an old example that I had. So a 5th root, you do 5 math and number 5 right here. Okay, we're going to plug in 5. And I need to put parentheses around it. 5 minus 1. Okay, close my parentheses, minus 2. Okay, so I've got that answer right there. Okay, f of 5 is approximately -0.68. We'll just go with that. Okay, but I'm going to store that as x because it didn't give me a nice pretty whole number. I'm going to store that as x so that I can just plug it in very easily into my other answer choices. But let me talk about for a second why I'm doing this. Okay, inverse flips x and y. So f inverse of -0.68 should give me 5. The x and the y values switch places. So I'm going to plug that number into my answer choices and see which one gives me 5. Okay, and I have to check them all. because sometimes, you never know, more than one might work, and then you need to pick another number, okay? So I'm plugging it into the first one. X plus 2 to the 5th plus 1. Does it give me 5? It does, okay? But I'm going to check the other ones too. Okay, the negative cube root of x, close my parentheses, minus 3. That definitely did not give me 5. Okay, C, the 5th root, math, 5 of, there's a lot of stuff here. Negative x minus 2, do what?
Can you have negatives in the square root?
Well, you can have a negative, you just can't, you can't take the square root of a negative number, but this number may end up being positive after applying all those negatives and subtracting 2. Okay, that did not give me 5. And then let's check the last one, 2x to the 5th minus 1. That did not give me 5. Okay, so it is answer choice A here. Okay, that's the only one that gave me 5 back as an answer. All right, so the multiple choice strategy is plug 5 into the original, get that answer, plug that answer into all the answer choices, and see which one gives you 5 back. Okay, see which one gives you 5 back. That's the easiest way to kind of check these if you've forgotten how to find the inverse. Now, a lot of the ones that you're going to have to find the inverse of are, I mean, they're really easy. It would be quicker and easier for you to just go through the process of finding the inverse than it is to plug in all the answer choices and check them and hopefully make sure you got all your parentheses in the right place. Okay. If more than one of these answer choices gave me 5 back as an answer, then I would have to pick a different number. Pick a different number like 3. Plug 3 in and check those 2 answer choices and see which one spits back out 3. It shouldn't do it for multiple values, but every once in a while, sometimes it won't work out. Okay?